Hello and welcome back. Today we will solve these three questions from past papers, and these questions are taken from the topic of diffraction grating. So we will solve these three questions to cover this one topic, diffraction grating, or also you can apply the same concepts to double slit experiment. And I should tell you that we are almost at the end of AS physics syllabus. So we are here right now. And after this, we just have one topic, which is photoelectric effect. So let's start with this equation, n lambda equals d sine theta, because this is the objective, right? We should be able to use n lambda equals d sine theta for diffraction grating. Now, I want you to repeat this exercise for any equation that you see in physics. For example, let's say we don't know what theta is representing, we don't know what d is representing, and we don't know what lambda or n means in this equation. Even without any information about what each variable in an equation is representing, I can still understand a few things about an equation. And the way you do it is you just try to understand how different variables in an equation are related to each other. So for example, if I ask you how is lambda related to d, the answer is that lambda is directly proportional to d. And you can see it from this equation. It means that if I increase d, lambda will also increase. Second question, how is angle theta related to lambda? And again, the answer is lambda is directly related to theta, which means if I increase lambda, theta will also increase. And they are linearly related, which means if I double lambda, theta will also increase 2 times. If I increase lambda 4 times, theta will also increase 4 times. Now, the question for you is how lambda and n are related. Now, to answer this question, what you need to do first, the variables that you are trying to compare should be on the opposite side of the equal sign. So you need to move this lambda, or you need to move this n to the other side of the equation. Let's move lambda to the other side. So we can write n equals d sine theta divided by lambda. Now you have an equation that tells you how n and lambda are related, and you can see that n is inversely related to lambda, which means that if you increase lambda, now n will decrease because it is inversely related. So I want you to repeat this exercise for any equation that you see. You don't know anything about the variables, but the equation is given, and just by looking at the equation, you can understand quite a lot actually about how different variables are related to each other. Okay, so next I will be going into the details of this equation and how to understand these graphs, for example, and these pictures. But if you want to skip to the part where we solve the questions, you can look at the timestamps in the description and skip this explanation if you already understand it. Let's talk about diffraction grating and how to understand these, for example, pictures. So what happens is that you have a diffraction grating, which is basically a plate which has many slits on it, and light can pass through these slits and it can diffract at different angles. And what you will see on the screen will be a pattern that looks like this. And what you're looking here is basically an interference pattern, and these bright lines are the points where light is interfering constructively. So this is constructive interference, and these dark spots or these dark lines are the points where light is interfering destructively. I've already explained constructive and destructive interference in my previous videos. If you are still confused about how constructive and destructive interference occurs, you should watch my previous videos. Here, I want to explain this diagram. So again, these dark and bright spots are shown on the screen, and this is the angle that different bright spots make relative to the central line, which is at the center of this diffraction grating. So for the central line, always the line or right in front of the diffraction grating or even double slit, you will always get a bright spot. The reason is that if, for example, I just draw 2 slits here, and this is the center point of the slits, the light coming from the top slit and the light coming from the bottom slit, you can see these 2 lines have equal length, which means the light coming from the top slit and the light coming from the bottom slit cover equal distance to reach this point. which means that the path difference between these two lights will be zero, right? There will be no path difference. And if you remember the previous videos, if there is no phase difference or path difference between lights, then they will always interfere constructively. And therefore, we call it zeroth order maxima. So zeroth order maxima. Zeroth mean that in this equation, n lambda equals sine theta, d sine theta. D sine theta is actually the path difference between light coming from different slits. So this is path difference, and n lambda means that it must be an integer multiple of lambda in order, if you are looking at maximas, for example, if you are looking at bright spots. If you are looking at dark spots, then this equation will change. It will be different, because for destructive interference, path difference should not be n lambda. It should be odd multiple of half lambdas, which you can write, I think, like this: n plus 1/2 lambda equals d sine theta. So if now I substitute n equals to 0, n equals to 1, 2, 3, what you will get from this part, you will get half lambda, 3/2 lambda, 5/2 lambda. So these all of these conditions for path difference will give you destructive interference. So I thought I should explain this difference, because I've seen some questions in past papers in which they start or they ask about the dark spots, and what students do is they use this equation instead of using this one, and they get wrong answers. So you have to be careful. If they are talking about maximas and not minimas, you have to use this equation. But if the question is about minimas, then you have to modify your equation and use this one. Again, if you don't understand how constructive interference happens for path difference equal n lambda, you have to watch my previous videos. Okay, so if I put n equals to 0 in this equation, I get path difference n equals to 0, and 0 times lambda will just give me 0, and the path difference will be 0, which I just explained that light coming from two different slits, they cover the same distance. That's why for the central spot, 0th order maxima, you will always have a path difference of 0, which means that the light will interfere constructively and you will see a bright spot. Okay, for n equals to 1, you will get first order maxima. For n equal to 2, you will get second order maxima, and n equals to 3, you will get third order maxima. And similarly on the other side. So this first order and this first order is just, the difference is that for this first order, we are moving in this direction, and for this first order, we have to move in the opposite direction. But you have to understand there is no difference. Now let's talk about this equation again, n lambda equals d sine theta. What each symbol is representing in this equation. This theta is measured from the central line. So you can see this is theta 1 for n equal to 1, theta 2 is for n equal to 2, and theta 3 is for n equals to 3. What you should be careful is that this theta is not this angle, for example, between n equals to plus 1 and n equals to minus 1. This is not the theta that we use in this equation, okay? This is not this theta. So if this angle is given, as you will see in one of the questions, they have given us this full angle between first maximas on both sides. So you have to divide this angle by 2, and then you will get this theta. Next, this d is actually the distance between two slits, or in other words, it is the distance or the width of one slit. N, as I have already explained, is the order of maximas, and lambda is the wavelength of the incoming light. For example, if you are using red light, so red light will have its own wavelength, and that wavelength you need to use here for lambda. One last thing about the concept of diffraction grating, I want to explain here that the 0th order maxima will always be the brightest, and if you plot the intensity of the maximas as a function of angle, right? So you will see that the maximas that are occurring at greater values of theta are less intense, and the maxima at the central spot is the brightest. So this will have the highest intensity, and as you move away from the central spot, the brightness of these maximas will decrease. Now in this picture, it looks like they all have the same brightness or intensity, but in reality, the central spot will be the brightest, and as you move in both directions away from the central spot, the consecutive bright spots in both these directions will be not as bright as the central spot. Okay, one last picture that I wanted to show you is this. So because white light is composed of different wavelengths, it has all the wavelengths in it. So n lambda equals d sine theta. I've already explained how lambda is related to theta, which means if I increase the wavelength, theta, which is the angle of diffraction, will also increase. Now what this means is that if I look at white light, because white light has different wavelengths, it has different colors, each color will be diffracted at a different angle. And for example, if a color has a longer wavelength, it will be diffracted at a higher angle. For example, if we take two colors, red and violet, we know that the wavelength of red is much greater than wavelength of violet or blue. Okay, so red light will be diffracted at a higher angle compared to violet or blue light. Because the wavelength of violet is smaller, it will be diffracted at a smaller angle. Wavelength of red light is greater, it will be diffracted at a greater angle. Okay, now I think we are ready to solve these questions. The first question is, light of wavelength lambda is incident normally on a diffraction grating that has a slit separation of 7 lambda over 2. That the question is, what is the greatest number of maxima that can be observed using this arrangement? Now, there are a few things that I want to explain. First of all, this slit separation is not usually the same as the width of a slit. For example, in a double slit experiment, the slit separation can be different, for example, from the width of the slit, which is this one. So this is D, but this separation is sometimes written as S, the distance between two slits. But for a diffraction grating, because also it is not given in this question, what is the slit width of the slit? So we will assume that this is just D, or width of the slit. And the next thing is the trick or the catch in this question is this number of maxima. So if you look at our equation, n lambda equals to d sine theta, most of the students will be very quick and they will say, okay, n is the number of maxima, right? So just solve this equation for n. But this is not correct, because n, like I explained in the previous diagrams and pictures, n is the order of maxima, okay? N is not the number of maximas that you will see, it is just the order of maximas that you will get. So for example, in this picture, we have n equals to 3, which is, we have a third order maxima in this diagram, but the total number of maximas are 1, 2, 3, 4, 5, 6, 7. So the relation between n, which is the order of maxima, and the number of maximas is always this, that the number of maximas will be 2n plus 1. 2n plus 1 because you have the same number of maximas on this side and on the negative side, and you also have to count the one in the center, which is n equals to, I'm sorry, I circled the wrong one, this one in the center, n equals to 0, right? So for n equals to 3, you will get 2 times 3 plus 1, which will give you 7. So this is the number of maximas. This n is the order of maxima. So you have to be careful with this. Okay. So if we have a light of wavelength lambda, how can we find the greatest number of maxima? This also you can understand from this picture. So what is the maximum number of maximum order for n that you can have? So you can see n is increasing as we increase this angle, right? So for theta 1, we have n1. For theta 2, we have n2. So if I ask you what will be the maximum angle for the maximum n, the maximum angle will be all the way from here to here, which you can see is 90 degrees. So the maximum order will occur for theta equals to 90 degrees, and sine 90 we know is just equal to 1, right? So you can just ignore this part. This is just 1 because theta is 90, because by definition we are looking for n max. So you should also remember this equation, that maximum order n will always be equal to just d divided by lambda. Actually, there is also sine theta, but by definition, if we are looking at n max, theta is 90, and because sine 90 is just 1, so we don't write sine theta here. Now, let's just substitute these numbers here. So d is 7 lambda over 2 divided by lambda. So the lambdas will cancel, and n max will be equal to 7 over 2, which will give you 3.5. Now, you have to be careful that, again, if you get a fractional value for n, you always have to round it to the nearest lower number, okay? So n max in this case is 3, but as you can see, 3 is not in the options. And like I just explained, 3 is the order of maximas, not the number of maximas. The question is asking about the number of maxima. So we can use our equation. The number of maximas will be 2n plus 1, which will give us 7. Now the second question is, white light is incident normally on separate diffraction gratings X and Y. Y has a greater number of lines per meter than X. So if Y has more lines per meter than X, it means that the width of individual slit will be smaller for Y because it has more lines or more slits. So this is smaller for Y, and D will be, the width of the slits will be large for X. Now the question is that 3 statements about differences between X and Y are given. Which statements are correct? The first statement is adjacent slits in the gratings are further apart for X than for Y, which is true because if the slit separation is small or width of individual slit is smaller, the slits will be closer to each other for Y, but for X, since the width of the slit is large, the slits will be farther apart. So this statement is correct. The second statement is the angle between red and blue light in a spectral order is greater in X than in Y. So we have to look at our equation, n lambda equals d sine theta. And this is the reason I explained at the very beginning of this video, even if you don't know anything about this equation, but this equation is given, how can you relate different variables? So this second statement is actually relating this angle theta with d. The question is, how will this angle theta change as we change d? Because for X and Y, d is different. Now again, to see this, the relation, we have to, the two variables that we want to compare, we must have those variables on opposite sides of the equal sign. So what we can do is we can divide both sides by sine theta, and then we can see the equation will be d equals n lambda divided by sine theta. So we can see that d is inversely proportional to angle theta, which means that if you decrease d, the angle will increase. Now let's see if this is consistent with the second statement. It says the angle between red and blue light in a spectral order is greater in X than in Y. But we can see that it is actually greater for Y than in X, because for X, D is greater. And if you increase D, then by our relation, theta should decrease, not increase. So the angle will be smaller, not greater. This statement is wrong. And the last statement is the total number of visible orders is greater for X than for Y. The total number of visible orders, which is n, is greater for X than for Y. Again, let's see how n is related to d. Again, from our equation, we can see that n is directly proportional to d, which means that if you increase d, n should increase. And we can see that for X, d is greater than for Y. So n should be greater for X than for Y, which is exactly what this third statement is saying, that the number of orders should be greater for X than for Y. So this must also be correct. So the correct answer is 1 and 3 only, which is option B. And finally, our third question. This question will also focus on a specific concept related to diffraction grating. By the way, I've not chosen these questions randomly. Each question is targeting a specific concept or a specific type of question that you can expect in the exam. So in some of the questions, you will see that they will not give you D, okay? So they will not tell you the width of slit. What you will be given will be something like this: a diffraction grating of n lines per unit length. So what it means that if you have a diffraction grating of length L, you will be given number density, which means n is the number of lines per unit length. Okay, so our goal is to relate n to D. So how do you think is D related to n? It is very easy. If you have some length and let's say L, and you have 10 slits in that length, and if you divide that total length by 10, this will give you the width of each line, right? So you see this length divided by number, and here n is defined as number of lines divided by length. So this thing is actually the opposite of n, which means it is 1 over n, right? Here we have number of lines per unit length, but in order to get D, we should have length divided by total number of lines, which is the inverse of n. So you should remember this relation that D is always inverse of number density. And the worst thing that you can do is connect this n to this n. I hope you are not thinking that they are the same. This n is the number of, n is the order of maximas. This n is the number density, which is related to D. The second thing is that sometimes you will see some questions, they will give you the angle between first orders. So you see here in our equation that I've written here, this angle theta is always measured from the central maxima, which is for n equals to 0. And we measure the angle from here, like I just explained in this diagram, right? So the angle that we measure is always measured from the central line, which corresponds to n equals to 0. But in this question, what they have given us is theta 1. Theta 1 is the angle between two first order maximas. So this is n equals to 1 above n equals to 0, and this is n equals to 1 below n equals to 0. And theta 1 is the angle between these two. So again, we need to connect this angle to this angle, the one that we have in our equation. And you can see theta will be theta 1 divided by 2. So let me write it here. And lambda will be equal to D, which we have already written in terms of n. I can write 1 over n, and 1 will be multiplied with sine theta. So it will be sine theta divided by n. So right now I just substituted D equal to 1 over n in this equation. Second, I want to replace this theta, and I want to write this angle in terms of this angle, because you can see in the options we have theta 1. So n lambda will be sine and theta divided by 2, theta 1 divided by 2, divided by capital N. So now we have our equation set to solve this question. The question is, what is the wavelength of the light, right? So they want us to find lambda. So if you rearrange this equation for lambda, by the way, what do you think n should be, this lowercase n for this question? Since we are working with first order maximas, so n will just be 1, and we don't need to move it to the other side. It will just be multiplied with lambda. Lambda times 1 is just lambda. And lambda will be sine theta 1 divided by 2 over n. So you can see it is option D.